This time we're supposed to draw the cosine wave, and please notice that the x-axis is supposed to be calibrated in degrees because the phase shift angle is expressed in degrees. The very first thing what we are going to do, we are going to write the equation for the reference cosine wave first. Simply copy down V equals 20 cosine omega t. Means you have to copy down 20 cosine omega t. This is my voltage peak, and this is my phase shift, my angle theta. Next, you're supposed to draw the graph. This is my voltage expressed in volts, and this is my angle theta in degrees. Next, I'm going to find the points on my x-axis, which are going to represent 180 degrees, 360 degrees, and 90 degrees, and 270 degrees, because the x-axis has to be calibrated in degrees because I have degrees over here. I have voltage peak 20 volts. Negative is going to be minus 20. I'm going to draw the dashed line in order to make my wave looking symmetrical. And first, we are going to draw the reference wave. Cosine wave. I have positive voltage in my equation. Means I have to start from the positive peak value. Remember, anytime you have cosine wave which starts from the positive voltage or current or from positive value, that cosine wave is going to have zero crossing, negative going at 90 degrees. Negative peak value is going to be at 180 degrees, and positive going, zero crossing, at 270, and positive peak again at 360 degrees. That's why my reference waveform is going to look like this. This is my reference waveform. Let me just draw this. V reference. This is not my answer yet. This waveform has to help me to find the answer to my problem. Next, please notice that we have positive 30 degrees phase shift. Anytime you have positive sign next to the phase shift angle, means you have to move your wave to the left side by this angle, by 30 degrees. How much is 30 degrees? 90 divided by 3 is going to give me 30. So this is 30 degrees. Means I have to move everything by 30 degrees. So my wave is going to start from this point. Next, my negative going, zero crossing, is going to be here. My negative peak voltage is going to be here. My positive going, zero crossing, is going to be at this point, because we have to subtract simply 30 degrees from every single point if it comes to the peaks and zero crossings. And also we have to subtract from 360 degrees 30 degrees, which is going to give me 330 degrees. 330 degrees, and this one is going to be 240. to 40 degrees. And this is going to be my positive peak. Next, I'm supposed to connect all these points together. So I have to connect my peak with the 60 degrees, and this one is going to be 150 degrees, because 180 minus 30 is equal 150. Next, I'm supposed to connect these 2 points together and these two. And this is the answer to my problem. Let's take a look at this example. My current peak is negative 8 amps. I peak is equal negative 8 amps. The phase shift angle is 40 degrees. What I'm supposed to do first? I'm supposed to write the equation of the reference wave first. The equation of the reference wave is simply I equals minus 8 sine 150 t. So this is my I reference, which is equal negative 8 sine 150 t. Now I'm supposed to draw the xy plane. This is current. Current is measured in amps. And I have peak values 8 and negative 8. I'm going to draw the dashed lines. Now, my x-axis represents the angle theta in degrees. Why in degrees? Because my phase shift angle is expressed in degrees. At this moment, I don't care about 150, as I said before. So I'm going to have points 180 degrees, and I'm going to have 360 degrees. Now, anytime we talk about the sine wave, we have to also talk about 90 degrees and 270 degrees. The sine wave is going to start from the negative half a cycle. Why? Because I have negative sine over here. Anytime you are going to have sine wave which starts from negative side first, you have to remember that negative peak value is going to be at 90 degrees. So this is going to be peak value of my reference sine wave. This is going to be positive going zero crossing at 180, and I'm going to have positive peak at 270 degrees and negative going zero crossing at 360. Next, I'm supposed to connect all these points together. Remember, this is 0. That's why I'm going to have something like this. This is my reference sine wave, I reference. This is not the answer yet. This wave has to help me to find the answer. This waveform has to be shifted to the right side by 40 degrees. Why is moved to the right side? Because I have negative sign. You have to keep in mind that anytime you are going to have negative sign next to the phase shift angle, means your wave has to be moved to the right side, no matter if this is cosine wave or this is sine wave. So I have to find approximately 40 degrees. So half of 90 is 45, So my 40, for example, is going to be here. So it means I'm going to have 40 degrees over here. 90 plus 40 gives me 130 degrees. 180 plus 40 is going to be 220 degrees. 270 plus 40 is going to give me 310, and 360 plus 40 is going to give me 400 degrees. It means that I'm going to start drawing my waveform from this point. My negative peak is going to be here. My positive going zero crossing is going to be at 220 degrees. My positive peak value is going to be at 310 degrees. My negative going zero crossing is going to be at 400 degrees. Next, I'm supposed to draw the wave. Simply connect these points together. And simply, this wave is the answer to my problem. As you can see, we moved the reference 40 degrees to right. One more time, we move this to right because this negative sign is telling me that my waveform has to lag my reference by 40 degrees. And this is the solution to my problem.